We want to establish if if the tangent is defined at x equal 2 in this function, in this piecewise function, and it transitions from one function to another at x equals 2. So basically, we want to know if there's a smooth transition. The first thing that we have to do, though, is we have to establish continuity. So to establish continuity, we need to make sure that the left-hand limit and right-hand limit at 2 equals the f value at 2. So as I plug in, as the limit as x approaches 2 from the negative side, I'm going to end up with 1/2. I plug it into this portion here. Okay, and then I'm going to establish the limit from the positive side. So I'm going to plug in x equals 2 from this side. So this is going to end up being 4 minus 2 divided by 4, which simplifies to 1/2. So the left-hand limit and right-hand limit are the same. So now we just have to make sure that the value at f of 2 is actually equal to 1/2. And if we use this one here because that's when it's equal to 2. And so that confirms it. So this establishes, first of all, continuity. Without continuity, we cannot have a tangent. So that's the first part. The second part then is we want to calculate slope. And we want to see if the slope is the same from the left side as the right side. So what I'm going to do is I'm going to use the slope ratio and let h go to 0, but I want to do it from the negative side of 0 for this section here. So I'm just going to highlight this. This is what I'm going to calculate first. So that is from the left side. So I have to approach 0 from the left side and let h approach 0. So then I have at x equals 2, I have 1 over 2 plus h, and again, we're going to approach that 2 from the negative side, minus 1 over 2, so the actual coordinate at 2, divided by h. And we're going to let the limit of this go to 0. So then, doing the algebra for this, we get the limit as h approaches 0 from the negative side. We're going to end up with 2 minus 2 plus h, over the common denominator of 2 plus h times 2, and then we're going to put the h in the denominator like that. So then simplifying this out, the 2's cancel out, so we end up with the limit as h approaches 0 from the negative side of negative h over h, and then 2 plus h times 2. So these cancel out, so then I can evaluate my limit at h equals 0, and then my limit is going to be negative 1 over 4. So from the left-hand side, okay, this is a rational function, okay, and from the left-hand side, I'm just going to start drawing this. So 1 over x at x equals 2, okay, it's a rational function, and it's going to have a graph that looks like this, and the slope at that point is negative 1/4, approaching it from the left-hand side. So then I'm just going to draw a tangent line here. So that's going to have a slope of m equals negative 1 over 4. So I'm going to see what's happening from the right-hand side. So let's choose a different color here. So I'm going to calculate the limit as h approaches 0, but this time I'm going to approach it from the positive side, and I'm going to use that expression there. So it's going to be 4 minus x plus h over 4. So it's not x, it's going to be 2. That's going to be 2 plus h. So my coordinate that I'm dealing with is 2, minus 1/2. That's going to be the y coordinate at 2. And that's all going to be over h. Okay, so I'm going to simplify this expression. I'm going to combine those terms. Okay, so this becomes, what's this going to be? It's going to be 8 minus 2 times 2 plus h minus 4. And that's all going to be over 8 and my h there. Okay, so simplifying this out, hopefully I can get rid of that divide by h. As h approaches 0 from the positive side, I end up with 8 minus 4 minus 4. minus 2h. So the 4's and the cancel out with the h's. So that becomes all 0. And then in the denominator, I end up with 8h. Okay, h's cancel. I'm going to use one more line here. So the limit as h approaches, let's do that in a different color here. Limit as h approaches 0 from the positive side, we end up with negative 1 over 4. So we can let h go to 0 now, and we end up with my slope is going to be negative 1 over 4. So what that means is that the slope from the left-hand side here and the slope from the right-hand side here are going to be the same. That means that the tangent is defined at that point, and it's defined as negative 1 over 4. So by sketching the rest of this graph here, the function, the piecewise function, that's going to be a reciprocal function again. It's a linear function, and it's going to have a slope of negative 1/4 and a y-intercept of 1. So from that side, it's going to look like this. Okay, it's a straight line, and since it's a constant function, we could have actually just looked at this graph and said that this slope here is negative 1/4. So we didn't actually need to necessarily do this whole limit here for this one, but we can see that the left-hand slope and the right-hand slope are equal. Therefore, the tangent is defined. Tangent is defined at x equals 2.